Hello everyone, I'm Xiao Gang. In the last lesson we wrote a multi-thread, but we didn't finish it, so a lot of problems came up. So in this lesson we'll continue working on it. Before we start writing, let's prepare a handy method to make logging easier. Because as you can see, if we log directly, there might be some potential issues. So we'll basically just use that handy method. 图拉格的 pre 图而立刻 Alright, right here. Let's create it here. Now we need to pass a parameter here. We'll just pass an effort say. We didn't do that kind of. We didn't write the variadic parameter approach. We didn't write the variadic parameter approach because that would be too troublesome to explain. We might as well just have it print a concatenated string code. Everyone can know that it can be written as a variable parameter method. And here we use an asynchronous task approach. Then we directly use this thing, which is very common for us. Generally, in this course, we will only cover these two core methods, which should meet most of our needs. Because our later examples will also follow this. These two methods are used for the architecture. Actually, there are many other methods. For example, some test graph tasks and some future mechanisms. That's fine. And here we don't need a return value. Okay, here. At this point, we just need to copy this value. And then we have already marked it to the main thread layer. Here. We'll just use log. Temp is fine. Actually, at this point, you can add an existing one, declare an existing log. It's also possible to debug this log specifically. Like this, share the log. Then we direct layer SA in here. Here. Directly a straight. Okay, good. This way we can print the log. Good. Let's put it here. Good. Here we include it in the CPP file. Do not include in the header file. If you include it in the header file, it will cause a problem, which is that there will be a circular dependency, making it difficult to handle. If you must declare related content in the header file, you can use forward declaration. Actually, it's best here to change it to forward declaration. That way, if it's not used, we don't need to worry about it. We directly include it. Okay, so we can't log it like this here. We need to do it this way. Okay. Then, what do we need to do next? Well, we have a print boarding here. Let's just write it directly here. The new ready-made is working. Okay, its effect is that it hits 0 targets every 40 milliseconds. Okay, since we believe there is no problem here, we set it to 0. Okay, at this point, there is a situation. This situation is that if you wanted to exit, right? If we wanted to exit, what should we do? Then we will use this external method. Adjust this stop, let it break out of this loop. Actually, we can do it this way. We give it a Boolean value like this. The Boolean is called B. Brown. Let's just call it brown. We set it to true. Okay, this value is definitely equal to true. When we initialize, this is one of its values. We can set it to true. Confirm once more. That equals to place. Then this place. It will come in. When we stop, we can set it to false. Right? Then here, when it first hears false, it will finish executing the current value. Then jump out. There is no problem with this. Then there is one issue. Actually, the threads here are different. Doing this will cause a crash. Then we can add a log here. Settle the daily funds for him. We can do it here. Exit again. Exit. then settle the daily fonts here as well. And output the page. Then take a look at the stop. Okay. Then we have a problem here. We haven't added a lock here yet. Let's not add a lock for now. Let's see if there will be a problem. I hope there will be a problem. But this is a thread race condition. It may not necessarily cause this kind of issue 100% of the time. Actually, we have two functions to explain. Let's put them here first. There is a untry2 here. Here we can use flint4. TLS should be this. This should be called a thread ID. IDC 空口海义空义形式空 U 空 seek. There is a get method here. Our behavior is missing an M. You can see when you click in, it also goes through Windows. This can return an identifier for this ID. We call this method. Call it directly here. Then we also have an FActual method that can get the current thread name. But we can set breakpoints to see that our county level process is also fine. So this place is an FActual manager. It should be FActual manager. Let's see if this class still exists. This is something the class has. You see it's at this position. We might need to include the header file. Next time, it will provide us with some management methods here. In this method, it has some operations, meaning we can directly get it. Obtain this singleton. It looks like a singleton implementation. Before we write it, let's include the header file. It's directly this dot. We observe that it is on the call above public call, so when we include it, we can just include it like this. Once we enter, we can get it. It has a method. This get obviously returns a reference, so we can just dot it. We can get an existing such name. Then at this point, this existing name, you will find that it requires an existing ID. So this ID is obviously the ID we obtained here. Right. Okay. After getting it, we can actually do a simple concatenation. Let me think about how to concatenate the string to make a loop pair. I'll pause here for a moment and concatenate this string. Okay, so we have concatenated it here, and this method, I hope to encapsulate it. I hope everything can be executed. We can do it this way. Let's dip it. Then if this character doesn't go through, we want to accept it. For info, we'll just call it xdinfo. Okay, we'll pass this directly in here. Then we'll prepare a method. We'll call this method on this thread. Since this method doesn't use any member variables, we'll protect it. There will be a multi-threading issue, because all its variables are directly allocated on the stack. We'll call it void print thread info. That's this method. Okay. Here, we'll keep it simple. We pull it in by hooking it up. Okay, this way we'll print such a log. So obviously, I want the time it prints to be. Then these places also need to print this place. This place only needs to print once. Ready to enter work. Okay, and then here we also print when exiting. We also print when stopping. We placed it after this. Like this, it is essentially a supplementary explanation for the previous information. Okay, there is a problem with this realistic approach of ours. We'll fix it later. Then, in this subsystem, within this subsystem of this thread, we expose it. Also, put a line. We will no longer let it follow and find. We need to activate it by pressing a key instead of doing it during initialization. This way, it will be more convenient for us when debugging. We give it an XG. Then we add a semicolon like this. This way, it can have a kind of secondary menu feel. Okay, that should do it. Then we need to set this place here. This place does not need it to intro, but we still hope that when we purchase it, we ensure that our thread is properly terminated. Okay, there is a problem at this point, because we have a race condition here. As you can see, there is an error. Let's fix the error first. Obviously, the problem occurred when printing the log. We can see that there is a place where we didn't add a signal. Let's check it. Found it. Obviously, it is here. This place did not add this signal because it needs to match something. It is very common to get this error when there is no match. So there is nothing special. Then let's start it up here, because there will be a race condition here. I already told you there will be a race condition here, because this place modifies this variable, and this place reads this variable. Okay, we will still test this part using key presses. Let's use 1 and 2. Didn't toggle. R. Okay, here we have a street. Okay, here we have an init. Simple street. We need to release this part. Okay. Okay, now let's test. Pay attention to our log. We press 1, press 2. Let's take another look at this log. No issues. Here it enters the thread pool. Then the thread in the thread pool. The elite thread is a new thread. Then it immediately enters work. That is also a new thread. Then it is working. Call stop. Calling stop is the main thread calling stop. No problem. Then after calling stop, it is still there. It will finish the current work. Then exit directly. Then the new thread exits at this point. There might be no problem here. You can take a look, no problem. This is completely fine. Then let me write this down for everyone. This is something to pay attention to. This is a new thread. This is not a new thread. It is on the calling thread of the external caller. Okay. Ignore this. Then let's add this lock for everyone. Add the lock. And since we are writing a lock inside, we usually write it like this. Here, we place the lock here. This lock will not be used externally. Okay, this is the lock. We generally should not use write locks. Write locks can cause serious problems. We usually use other methods to avoid write locks. So this lock has a method. You see, it is written like this. For example, here we're running, we first sleep. Then if we add a lock here, because we need to access this variable, it is written like this. So we lock it. You can see the scope of the lock. It is specifically used for locking. And this kind is when it is being destructive. It will release this critical section. That is, the locking value serves this purpose. That is, when it executes this piece of code, it is mutually exclusive with other code. And just like here, it is locked. And we also lock it here. Right? So locking it like this, after locking, it means this code. And these subsequent pieces of code, that is, within its life cycle, the code after this point and the code here, the code after this point are mutually exclusive. Then we access it here. Access means if the B running here, it is changed. If it is a force, 但是带换还档带夜四 breakout, and then this way it won't. It will be safe. That race condition won't occur, where you read and write a piece of data at the same time, causing such a problem. So this is a complete usage of a thread. We can let everyone use it again. But obviously, in this case, it will cause a problem. If your main thread happens to be, it will very likely have to wait 40 milliseconds. It just locks it exactly. It might wait 40 milliseconds. This situation can happen. It's because you need to wait for another thread. Okay. Then at this point, we initialize again, work again, then finish. Initialize again, work again, finish again. Okay. This method is completely fine. That is, there is no problem at all. Look, you will find that each time this thread's ID, look, that is the second ID. Look, the first one is always 44,268. And the second ID, it is different each time. This proves that the thread we use each time, it is always the same. After you use it, it is always different. It creates a new thread. It always creates a new thread. This is actually very good. You should adopt some thread pool design. But you basically use this coin ensure that your can have its own thread to perform the task you want to do. Okay, so that's all for this lesson. In the next lesson, we will talk about how we can use some ready-made safe classes to implement certain functions. Thank you, everyone.